Hi, and welcome to this presentation on how ACC can fit right into a digital factory workflow and become the single source of truth to exchange assets and digital plant layouts to the wider team, including architects, structural engineers, to finally come to a digital twin that leverages all information from designing, constructing, and commissioning a factory. It has been clear for quite a while now that in order to operate a factory, we need to leverage the information that is being stored within a digital factory layout to truly benefit throughout the entire life cycle of a plant. But still, currently we see a lot of data is being tossed around, and with each stage throughout the project execution, the information is being dumbed down, and we experience a loss of information when handing over the digital plant between the different stakeholders. So what's the solution? A cloud environment in which data is being stored as and when it is being created. This will allow us to not only share information and enrich our models as they become available for the wider team, but also to plan with the end in mind. Conversion of these models into actionable assets that can live through to facilities management. To do so, Autodesk provides a wide range of tools to do exactly so. From planning a factory through design tools such as Inventor, Revit and Navisworks, the factory design utility and Volt, over building the project using the Autodesk Construction Cloud portfolio to maintenance with Autodesk Tandem. In the next couple of slides, we'll be focusing on 3 specific workflows that will help a factory owner to control all of its resources from conception to commissioning. We'll cut this slide up into bite-sized chunks that explains how data gets integrated into our single source of truth and leverages all aspects of the digital factory, whether it's the factory equipment supplier, the architect who needs to deliver his design in context of the factory layout, or the construction team that will actually have to install all of the equipment on site. So let's start with the factory equipment suppliers. This is a highly competitive market in which the demand can vary from repeatable designs to bespoke machinery. So from a supplier, it is critical that his time to market is as efficient as can be. Obviously, Autodesk already provides tools that can help with the design of this equipment. What we're focusing on here is how the finalized equipment or factory layout can be sent without loss of information to stakeholders downstream, such as architects, engineers, etc. Within Inventor, we can use tools to convert an Inventor assembly into a Revit model that can either be stored inside a Vault and synced automatically to ACC, or indeed to send out the equipment to a Revit designer who can incorporate it immediately into his own design and upload directly from Revit into ACC. We could of course continue the Inventor data without simplification, but there really is no point in doing so, as we only need to be able to see equipment in context of the total factory design. Imagine one type of equipment reoccurs several times within the factory and all the nuts and bolts within the machine have been exposed. This would make the aggregated model top-heavy without serving any purpose. From an integration point of view, we only need a correct envelope representation with the relevant technical connectors exposed. So now that we have delivered the content of the shop floor, it is time to put this in context of a building during the building's design phase. Obviously, what's most important here is that we can identify clashes early on and that we can see all different aspects of the building in context. This, of course, doesn't just apply to machinery and its operational zone, but also to MEP data that is brought into context. This is where Revit, Autodesk BIM Collaborate or Autodesk BIM Collaborate Pro and Navisworks come in play. We can also leverage Autodesk Docs' powerful data exchange to bring building data back into Inventor. Once the design is finished, it's time to start thinking about making this real for the factory owner. This means not just having well-designed 3D objects, but also attaching relevant data to the assets, such as manuals, checklists, etc. So as we move on from conception and design to construction and installation, we need to find a way to reduce the cycle between the field and the single source of truth so that in the end, the owner gets what he's asking for, a digital twin of his factory. This is where Autodesk Build comes into play. More in particular, Autodesk Build allows us to extract asset information from design files and therefore to add construction information to these objects, truly gearing up towards asset management. Now that the factory has been built, it's time to hand over to the owner and look at maintenance from his point of view. It is clear that good design and correct construction is a critical aspect of any building's life cycle, but of course the story doesn't end there. On the contrary, where these first stages can span up to a couple of years, the maintenance of the building can continue for several more years, understanding operational space usage, IoT, and indeed spanning not just one building, but several. Before we move into digital twins, let's define what a digital twin can look like. We can identify 5 levels of maturity in digital twins, each level adding more value than the previous ones. The first level is called the descriptive digital twin, a live and editable version of the design, as well as the construction data. Moving on, we get to an informative twin, which also brings in operational and sensor data. Next, we get to a predictive twin, in which we take this information and use it for insights. Following is the comprehensive twin, which adds simulation and what-if scenarios to our model. And finally, the autonomous digital twin. The model learns for itself and can act on behalf of the users. With Tandem, we are already at the stage of delivering a descriptive, informative twin. So really, what Tandem brings to the table is indeed a single pane of glass through which we can understand assets relative to the different technical systems, but also in context of the rooms and spaces these assets belong to. Rather than delivering 2D sheets and loads of paperwork, Tandem can help us in understanding our building, color-coding assets based on properties, following up on the maintenance history of our assets, and indeed attach IoT streams information so that we can follow up on the building's operational status. Hopefully you've enjoyed watching this overview presentation on how Autodesk can help in bringing the different aspects of a factory's life cycle together. Whether help is needed in the design using tools such as Inventor and Revit, or during construction with Autodesk Construction Cloud, or bringing maintenance to life in our digital twin solution, Tandem, the integration of all these tools ensure that data continuously gets enriched throughout the process, ensuring optimal communication across all stakeholders, no matter where, when, or who.